Okay, so today we're going to continue using CTS, or completing the square. We're going to do it the same way we did on Friday, but we're now going to take it one step further and use it to solve. Okay? Completing the square is a process to solve that will work anytime. Okay? It'll work anytime. You can use it anytime. I wouldn't necessarily recommend using it that often because I think if you can factor and solve, you should. And then I think if you can't factor and solve, you should use the quadratic formula, which we're going to review tomorrow. Okay? But it is a good tool, and I know some people really like it and would rather use it to solve, so to each their own. But let's go ahead and try this. We've got x squared plus 4x equals negative 7. Okay? Now, anytime I solve, or I'm looking for the solution, or I'm looking for a root, or I'm looking for a 0, or I'm looking for an x-intercept, those all mean the same thing, remember? Anytime I'm trying to solve, what do I like to get it set equal to? 0. So what am I going to do? Add 7. So I'm going to have x squared plus 4x plus 7 equals 0. Okay? Now let's go ahead and turn this into vertex form. Let's use completing the square and turn this into vertex form. Okay? So remind me what I do. Okay, move the 7 over. So I have x squared plus 4x plus 7 equals 0. Okay? All right, then what do I do? Yep, get your b value of 4, and what do we do to it? Half it, and we get 2. Box it, square it, and we get 4. Then I write it. What do I write? Plus 4. And then how do I counteract it? Minus 4. Okay? We turn our first 3 terms into a binomial squared. What binomial squared does this turn into? X plus what? 2. Where do you get that number from? Yeah, your box. Okay. So I have x plus 2 squared plus what? 3. Now, looking at this, is this now in vertex form? Yeah. What would be my vertex? Negative 2, 3. Okay. Set equal to 0, I can continue from here and solve. Okay. So from here, I can go ahead and solve this. Notice I only see x in one place now, so I can continue and solve. What do you think I would do first? Subtract what? Yeah, let's subtract the 3. I'm going to rewrite what I had first. X plus 2 squared plus 3 equals 0. Okay, and then I would agree we'll subtract 3. And I get x plus 2 squared equals negative 3. What would I do next? Square root both sides. So I've got x plus 2 equals, when I write in the square root of negative 3, what must I put in front of it? Plus or minus. Okay, can the square root of negative 3 be simplified? Yeah, how would I write it? Okay, so plus or minus I root 3, or you could write root 3I. No, you cannot say 3I. Think about it. The square root of negative 3 is the square root of 3 times the square root of negative 1. Square root of 3 stays square root of 3. Square root of negative 1 becomes I. Does that make sense? If you multiplied x plus 2 squared, you'd be right back up here. And that you can't solve using, unless you use the quadratic formula. Okay? All right, we need one more step. What do we do next? Subtract 2. You're going to see this written in standard form for complex numbers. So you're going to write negative 2 plus or minus I root 3. You've got to have your real number part and then your complex number part. I don't know. Okay, so let's talk about this. Tell me about these roots. They're what? Okay, so these are complex or non-real solutions. So what do we know about the graph? The graph never touches the x-axis. How many complex solutions are here? 2. You could split these if you wanted and write it as negative 2 plus I root 3 and negative 2 minus I root 3. You do not have to, though. But if you want to remember that these are 2 distinct solutions, you can go ahead and split it. Not on the xy plane, no. But we're not going to spend time with that. Okay? Questions? Okay? All right, let's try another one. (3x squared plus 6x equals 1). So we're going to solve by completing the square. What would we do first? Subtract the 1. So I'm going to get 3x squared plus 6x minus 1 equals 0. Okay, what would I do next? Pull out the 3. Because 3 goes in evenly to 3 and 6? Is that why I'm pulling out 3? No. Why am I pulling out 3? Good. It's your a value. So whatever your a value is, you've got to pull it out. So 3 times x squared plus 2x. Leave yourself some space. All righty. What do we do next? My b value, which b value do I use, 6 or 2? 2. All right, half it. What do we get? 1. Box it, square it. What do we get? 1. I write it. What am I going to write? Plus 1. And I counteract it. What am I going to use to counteract it? Good, minus 3. Everyone remember why it's minus 3 and not minus 1? Okay. All right. How do I rewrite this? Three times x plus 1 squared minus 4 equals 0. All right, now if my goal is to solve, now I'm going to start isolating my x. So what would I do first? Add 4. So I'm going to get 3 times x plus 1 squared equals 4. Then what? Good. So x plus 1 squared equals 4/3. Then what? Square root it. So I'm going to get x plus 1 equals, what do I need in front of my square root? Plus or minus the square root of 4/3. Okay, now I'm going to pause here for just a moment. Let's take this square root plus or minus the square root of 4/3, and let's go over here and try and simplify that. You can do it all in the same line. It just might get tedious. So I'm going to go off to the side and do this. So I've got plus or minus square root of 4/3. What would you suggest I do? Okay, split it. So square root of 4 over the square root of 3. What's the square root of 4? So this is plus or minus 2 over root 3. Then what would you have to do? Yeah, I have to rationalize the denominator. So multiply the top and the bottom by root 3. And what do I get? Plus or minus 2 root 3 over 3. Questions on any of those steps? Okay, so I'm going to come back down here. So I have x plus 1 equals plus or minus 2 root 3 over 3. Last step, subtract 1. So I'm going to get x equals negative 1 plus or minus 2 root 3 over 3. Oops, not over 2, over 3. All right, talk to me about what kind of solutions these are. These are real. Good. So what do we know about the graph? Touches the x-axis. Where's your vertex? Yeah, from this step right here, from completing the square. So that makes sense if you think about it. Where your vertex is at negative 1, 4. Or sorry, negative 1, negative 4. Look at your a value. What's your a value? 3. Which way does this graph open? Up. So doesn't it make sense that we have two real solutions? Yeah, because how many times does it cross the x-axis? Twice. Okay? All right. I would like for you to try these. I'm going to give you a couple minutes to do this on your own. Okay? And then we will come back and check your work. If you are watching this video, you can pause the video and then turn it back on when you're ready to check. Okay, so let's see how you did. On number 3, when you got this into vertex form, you should have 0 equals, or you could have the 0 on the other end, x minus 4 squared minus 4. Everyone get that? No, you need me to do it? Okay. All right, let's give it a try. So I'm going to subtract 8x. So I'm going to get 0 equals x squared minus 8x. I'm going to move my 12 over. Okay. Everyone okay with that? All right, so what's our b value? Negative 8. So half it. What do we get? Negative 4. Box it, square it, and we get 16. So I need to add 16 and subtract 16. So this is what gives me x. Look at your box number. It's negative 4, so x minus 4 squared. And then plus 12 minus 16 gives me negative 4. Everyone okay with that? Did you find your mistakes? So then you would have to pull out a negative before, so you should have a negative out front of here. Yeah, that would be okay. Okay. In the future, though, wherever x squared is, you need to leave it there, because this is meant to be an upward-facing parabola. Okay? So for future, yes, you would still be fine. But in future reference, wherever x squared is, as long as it's positive, leave it there. If it's negative, you have to leave it there. Okay? Okay, so to solve this, what do you do first? Add 4, so you get 4 equals x minus 4 squared. Then what? Square root it. So you get what? Plus or minus the square root of 4 equals x minus 4. Okay, then what? Yep, this is plus or minus 2 equals x minus 4. Then what? Add 4. So you get 4 plus or minus 2 equals x. You can't stop here. You know what 4 plus 2 is, and you know what 4 minus 2 is. If you have simplified numbers like this, you cannot stop here. You have to go ahead and tell me what your two solutions are. So what is 4 plus 2? 6. And we have 4 minus 2. So what are your two solutions? 6 and 2. Okay? Do not stop there. On a test or a quiz, if you write me 3 plus or minus 2 over 7 or whatever, that's not okay. If it's no radicals, it's all whole numbers, you have to split it and give me the two answers. Okay? All right, let's look at 4. For your vertex form, you should have gotten x plus 3/2 squared plus 11 over 4 equals 0. That would be positive. So let's look at this. So you've got x squared plus 3x plus 5 equals 0. Take your 3, half it, get 3/2, box it, square it, you get 9/4. So you have to add 9/4 and subtract 9/4. Okay, so this gets rewritten as x plus 3/2 squared. Positive 5 is how many fourths? 20/4 minus 9/4 is positive 11/4. Everyone find their mistakes? Okay. Let's go ahead and solve this. We're going to have x plus 3/2 squared equals negative 11/4. What do? Square root. So we get x plus 3/2 equals plus or minus the square root of negative 11/4. So we get x plus 3/2 equals plus or minus. What happens with the negative? Comes out here. Okay, and then couldn't I split this as the square root of 11 over the square root of 4? And what is the square root of 4? 2. So this is I times the square root of 11 over 2. Sure, that would be fine. But this whole thing is negative, so the I is multiplied by the whole fraction. No, you may, but just understand that I is being multiplied by the whole fraction. Okay? All right, and then subtract your 3/2. X equals negative 3/2 plus or minus. I would probably rewrite this as root 11 over 2i. No, it doesn't matter. It's just what you'll see more often. What other questions do you have? What do we know about these solutions? They're not real. Okay, they're complex, so that graph doesn't touch the x-axis. Okay?